Hello students, welcome to physics class. My name is Madhu Kashyap. I'm an astrophysicist. Actually, I basically teach physics at a degree level, and I enjoy teaching the basics in 11th and the 12th grade for CBSE. So let's get into the part of elasticity, which is one of the important and very interesting topic by itself. This is a demo video, so this will be a short description about elasticity and plasticity. So that will be the outline of my talk. Let's go and see the definition of elasticity. The definition of the elasticity says the ability of the body to regain its original shape on removing the deforming force within the elastic limit. So we have three main things: original shape, deforming force, and elastic limit. These are the three keywords. What do you mean by original shape? Imagine if there is a slinky like this. This is my daughter's slinky. You have seen a slinky, right? You would have played with this kind of rubber, or you would have seen rubber bands. So those are elastic materials. So this is one of the examples for elastic materials. So I apply a deforming force in the form of an external force like this, and I remove the deforming force. It comes back to its original shape. And this happens within an elastic limit. What do you mean by an elastic limit? Elastic limit is a limit where if I put too much force, and if I break it, it will cut into two halves. That is the limit. You can only stretch only until as much as this material can withstand that. If you apply more force, it's gonna break apart, and it's also called as a fracture point. That's a topic by itself when we study something called as stress and strain curve in the future classes. The perfect example for elasticity is quartz fiber. We can just see these are the quartz fiber, which is generally used in understanding the perfect elastic body. In nature, you find elasticity in many places. Where do you see elasticity much in action? If you ask me such kind of question, elasticity can be seen in building bridges. In bridges, when if you have seen bridges and flyovers, you would have seen two heavy weights like a U shape, which is hanging with two heavy weights are hanging around. That is due to just to check the elastic nature, and we also to check the elastic limit of the bridge, so whether it can withstand that much heavy vehicles on it. And also elasticity is seen as an application in building your own homes. You have pillars. All those things are basically understood using elasticity. So this is a very interesting topic and very important topic, and you can apply it in many places. So if you are studying physics and if you are applying it, elasticity is the way to go. Okay. When we learn elasticity, there has to be a contrary for it. So the contrary is called plasticity. So in elasticity, you understood elasticity, right? It's a very simple thing. It was the ability to regain its original shape, elasticity. But plasticity is the opposite, inability of the body to regain its original shape or size on removing of the deforming force. So for this, the perfect example would be a water bottle. You take it, crush it does not come back to its original shape on its own. So after removal of deforming force, it's not coming back to its original form. And the perfect example for plasticity is silly putty, which is seen on walls. Before painting, you have seen people, painters put these white plasters. This is basically putty. It's a plasticity material gives you longer durability, because plasticity has the nature of being giving you longer duration. Is it clear? So the two things what we understood: elasticity, it when I remove the deforming force, it's coming back to its original shape, whereas plasticity does not come back. So these are the very two key points of understanding the definition of elasticity and its contrary. So let's look at a quick question. The body will regain its previous shape and size only when the deformation caused by the external force is within a certain limit. What is that limit? The options are A, plastic limit; B, elastic limit; C, deformation limit; D, none of the above. You can answer this question in the comment section below. I'll be happy to acknowledge those things. And the correct answer is, as you people say, It's the B, elastic limit. So if there is an elastic limit, is the limit of beyond which the system breaks down. So if you like these kind of things, you can always come back and watch my videos. Thank you very much.